Do you think Mr. White ate all the donuts? Oh my goodness. Do you think I did it? That, whatever you just put there, whatever you just thought or typed, is called a conjecture. A conjecture is something we believe to be true. So some of you said, no, Mr. White would never eat that many donuts. And some of you said, yep, looks like Mr. White ate all those donuts. How dare you? How dare you? I'm so offended. When you make a conjecture, right? So when you said, Mr. White ate all the donuts, that is something that you think to be true. That is called a conjecture. It's a fancy word. Then when we make a conjecture, right? When we say something we think is true, we then have to go find proof for that. So you're going to, if you think that Mr. White ate all those donuts, what kind of proof would you look for? Yeah, right. Crumbs on my shirt, right? Maybe a bag or a piece of a donut in my car that I didn't finish. That is part of your argument. So I want to, this is in your SRB on page 12. I want to read a piece of it to you. You're always welcome to go and read the rest. When making conjectures and arguments, there's our heading. When solving problems, people often start by making a conjecture. A conjecture is a statement that might be true. In mathematics, so here's the difference, right, between this and the donuts. In mathematics, conjectures are not simply guesses. They are based on some information or mathematical thinking, right? So you don't just make a random guess on a problem, right? On a problem that you're solving. Mathematical reasoning that shows whether a conjecture is true or false is called an argument. You can use words, pictures, and symbols when you make a mathematical argument. Okay, so this is what we're going to do. We're going to be making a conjecture and then trying to find the proof and evidence for that is part of our argument. Okay, and there is our objective today. Our objective is that we will be able to use clues to make conjectures and arguments about the total number of chairs in a room. And it goes with our problem-solving standard. We are working to make sense of problems and persevere in solving them. Persevere, right, is the word that means like if something is hard, we don't just give up, right? If something's hard, we don't just say, I can't do this, I'll never do this, I give up, right? That's not perseverance. Perseverance means that we look for things that we can do and we look for ways that we can start the problem and do our best work here. So let's open up to Math Journal page 261. All right, on 261, Mr. White's going to do some modeling here for you about how we would make a conjecture, and how we would, try to develop an argument, right? We've actually got a conjecture here. Here we go. Miss Soto is setting up chairs for math night. Okay, got that picture in your head? Her room cannot fit more than 35 chairs. She places the same number of chairs in each row. As she sets up the chairs, she makes up a problem for her class with these clues. All right, here we go. Clue A, when there are 2 chairs in each row, there is 1 leftover chair. When there are 3 chairs in each row, there is 1 leftover chair. When there are 4 chairs in each row, there is still 1 leftover chair. When there are 5 chairs in each row, there are no leftover chairs. Use the clues to figure out how many chairs Miss Soto set up. Okay, now, notice that it says she cannot fit more than 35. So the number of chairs doesn't have to be 35. But that's the biggest number that it could be. But now we have one of her students. Joy is one of Mrs. Soto's students, and she makes a conjecture. She says, Miss Soto set up 13 chairs. Work with your partner. We're going to watch me. and use the clues to make a mathematical argument for or against Joy's conjecture. You may draw pictures, definitely want to use that, or use counters to show your thinking, explain your reasoning. All right, there's a lot there, guys. So she thinks 3 chairs. So clue A was that if there are 2 chairs in each row, there's 1 left over. So I'm going to set up 2 chairs in each row. 2 chairs in each row, right? And I'm going to get up to 13. 6, 7, 9, 10, 11, 12, 13. So this 13 works here. Okay, 13 fits clue number 1. Let's put a check mark right there. You can be drawing these arrays with me. I'm going to use arrays. We could use counters, right? We could draw pictures of each desk, but I think it's easier to do an array, but it's up to you. When there are 3 chairs in each row, there is still 1 leftover chair. All right, we're going up to 13 still, right? We're testing Joy's conjecture. 5, 6, 7, 8, 9, 12, 13. Oh, that one works too. All right, when there are 4 chairs in each row, there is still 1 leftover chair. 7, 8, 9, 10, 11, 12, 13. It works. And when there are 5 chairs in each row, there are no leftover chairs. This one smells trouble for me because I know what numbers I'm going to say if I count by 5s. Let's put groups of 5 here. 9, 10, 11, 12, 13. It fell apart. So we are going to make an argument against Joy's conjecture. We believe that Joy is incorrect. Okay, and we would say Joy, ooh, that's so big, is incorrect because her conjecture does not match with clue number 4, right? When there are, I'm going to describe it a little. I'm going to describe this picture. When there are 5 chairs in each row, there are 3 extras, not 0, like Joy thought. Okay, so what do you see here from the work that Mr. White did? There's 2 things that we see on this page. What do you see? Hey, you see our drawings, right? And then our explanation, right? We have to explain our reasoning. That means to explain our thinking. All right, let's go on together here. We've kind of talked about all these questions as we've been going. There's our objective here to be able to solve. Why can't we get that up on the screen? There we go. To make conjectures and arguments about chairs in a room. So I'm going to focus on this part here together. Oh, too small. Bigger and bigger. This is going to be the one that you help me with. All right, so that we've got we still have Miss Soto setting up chairs here, and we still have the same clues. And so the question says, how many chairs do you think that Mrs. Soto set up? So use your mind here and think about, well, we know that 13 was wrong. We know the answer has to be less 35 or less. How many chairs do you think that Mrs. Soto set up? All right, we're going to test it. Now, probably several of you were thinking about how in order for there to be 5 chairs in each row, there has to be no leftover. So we know it's got to be a multiple of 5. right? 5, 10, 15, 20, 25, 30. We're going to test 15. 15 chairs. And we're going to see if they fit the clues. So I would like for you to draw. Well, let me do the first one and then I'll have you do the next. We're going to do clue A. There's 2 chairs in each row. And let's get up to 15. Oh, I'm going to need more room here. 6, 7, 8, 9, 10, 11, 12, 13. Why I still don't have enough room? 13, 14, 15. Ah, good. So 15 worked with clue number 1. Okay, there are 3 chairs in each row now. We're going to see if we get 1 left over. We're doing 15 chairs. 9, 10, 11, 12, 13, 14. Oh no. What happened? Why does our array not match clue B? It doesn't match because when we put 3 chairs in each row, there was supposed to be 1 leftover chair, right? So we could type a sentence that says, our first conjecture was incorrect because it didn't work for clue B. Let's pick a different number, right? We know that it's going to be, in fact, let's erase here. Make all this go away because that ended up being wrong. That's okay, right? We know that it's going to be multiple of 5, right? Because if there's 5 chairs in each row, there's no leftover. So it's either 5, 10. We know it's not 15, 20, 25, 30, or 35. All right, now I want you to draw the arrays for the number that you picked. Take some time and draw the X's and see if the number that you picked is the correct amount of chairs or if it isn't. And it's okay if you find out that you were wrong. That's fine. But I want you to spend the time drawing those arrays. See if you picked the right number. All right. So how do you know that your number that you chose was correct or incorrect? How do you know? Okay, it's going to depend on the number that you picked, right? Because if you picked a certain number and it matched all of the clues, then that worked. And if you picked a certain number and it didn't match all of the clues, then that's fine too. Now you know you're wrong, right? What we're learning here today is how to make a conjecture and then how to prove it either correct or incorrect. All right. That is our goal today. We are going to be working on, let's see if I got it over here. Oh, there's the objective and our standard. We're making sense of these problems and problem solving. Oh no, it disappeared. Is it over here? It's, there we go. Perfect. It is HomeLink 8.4. You will find it in your HomeLink book. And you have a little note about what we've been working on today, and then a situation where now we have members in a band. And they need to march in equal rows. Okay, so I'm going to let you read this carefully. You'll end up with 2 pictures here. 2 pictures. And then you'll do some explaining, right? Which way do you think is better? And explain your reasoning. So you need to give your answer and then your explanation also, right? Be sure to explain your answer. All right, 3rd graders, if you need any help with conjectures or arguments or organizing chairs in your classroom, please reach out, let me know, and good luck.